It is very important to understand the difference between a statistics and a parameter. It is one of the very important concepts in statistical analysis of data. And let me explain. There is a question: how would you estimate the average annual family income in the state of Michigan? That is the task given to you. How would you go about it? You really have two choices. You ask every household of the state and collect the relevant data about annual family income. You have to ask every household. Or you can take a representative sample, a subset of all the families in the state, collect data for each family, and estimate the average annual income. Now, which choice is better? The first choice is difficult to follow since the number of families in a state is typically very large. That is always a problem. Our population that we deal with, the population size is always very large. We cannot ask individual member of the population. The second choice is preferred because it requires less effort. The critical issue, however, for the second choice is to identify the set of representative families. How would you get a set of families that represent the entire population? We'll be discussing this in later modules. Now, here's an important point to remember. On a given day, the average annual family income is an unknown constant if we do not allow new families to join or leave the state. This is an example of a parameter which is related to the entire population. Average family income in a state is a parameter which is a constant at any given point in time. We typically cannot estimate it because of large population size. That is the major problem. Our second choice allows us to estimate the average annual family income based on a representative sample. Now, this is an example of statistic. Our statistic is a function of sample data and is a random variable. Once again, our statistics is a function of data that you have collected and is a random variable. For example, if we estimate the average family income based on 100 families surveyed, I've just picked up a number, 100 arbitrarily. Every time we take a random sample of 100 families, we are going to get a different average. Sample average is a statistic and it is a random variable. A statistic is estimated from a sample. Examples are sample average, sample standard deviation, sample proportion. Our statistics is to be treated as a random variable. This is an important understanding. A statistic is to be treated as a random variable. Another randomly drawn sample will give you a different statistic. We estimate a statistic and use it to draw inference regarding the corresponding parameter of the population. This is a very important concept. We always estimate a statistic and use it to draw inference regarding the corresponding parameter of the population. So for every parameter, we can associate a corresponding statistic. Parameters are difficult to be estimated, So use a statistic to draw inference about the parameter. For example, we use sample average, the standard notation is X bar, to draw inference about population mean, which is represented by the Greek symbol mu. So X bar is a statistic. We take a representative sample, get individual values, get an average, that's a sample average. And we use it to make inference. We'll explain that, what we mean by that in later module. We make inference about the corresponding parameter, which is mu. The following table shows some examples of statistics and corresponding parameters. For example, sample average X bar is a statistic. Corresponding parameter is population mean, represented by mu. Another example, sample variance. You collect a sample, you can estimate the variance of the sample. How is the data? It's a measure of variation of the data, individual data element from the sample average, represented by small s squared. Corresponding parameter is called the variance. It's a very important parameter of a distribution and represented by Greek letter sigma squared. Another example, sample proportion. Sample proportion is used a lot in quality control. You take a batch of 100 parts that may be made in an hour. You compute how many defective parts you had. Let's say you had one defective out of 100. Then your sample proportion is 1 over 100. Your X is 1, number of defective parts. N is 100, your sample size, as an example. So in this case, your sample proportion from the randomly drawn sample is, from that batch, is 1 over 100. And corresponding parameter is represented by small p, is known as fraction defective. So we may state that a process is giving on average 1% fraction defective, which is making about, on average, one good part every 100 parts. Okay.